I wanted to discuss a question of electrochemistry, which is the cell in which the following reaction occurs. And there's this reaction has E naught cell is equal to 0.236 volt at 298 Kelvin. Calculate the standard Gibbs energy of the cell reaction, and it has given you the value of F. This is some extra information that I wanted to give, just in case you want to do some other questions and you have some sort of doubt in solving them. So, if the question was you have to find like the E cell, right? If you had to find out the value of E cell, if that was the question, and if it says that it is the reaction occurs at this temperature, in this temperature 298 Kelvin, then you have to understand this reaction and the dissolving of E cell requires this constant, and this constant is the constant for 2.303 RT upon F. Since all of this is constant, right? At temperature 298 Kelvin or 25 degrees Celsius, you can use this particular constant and get the answer. But this sort of constant will not be used in this question. Okay? So let us find the answer. It has asked you to calculate the standard Gibbs energy of the cell reaction, and it has given you the value of F. This is like the approximate value of F. So let's do it. Over here we have to find delta G naught, right? So delta G naught, what is the value of delta G naught? It is minus NF E dot E naught cell, okay? Minus NF E naught cell, right? Over here, if you look at the, if you actually look at the equation, the whole formula, the whole reaction, if I am be more precise, we have taken this to be 2 electrons, right? And this also of 2 electrons. So if I write it over here first, to explain if I want to write it. Okay, so I wrote it over here. And over this, like when it comes to this thing, right? A mistake can be made where someone writes the value of it to be as 6. The value of n to be 6. Why? Because usually we have a question, whenever we have this sort of question, right? We see 2Fe as a whole. We don't really see it as 2 plus, right? So we will just assume that it's 3 electrons, but that's wrong. Over here it says that from 3 it came to 2. Okay. And for here it came from, so that means it gave you only one electron. Only one electron was added to this thing, to this whole reaction. When it comes to this, as you can see, it's 2 electron. Right, because if it was if it was like I negative to I, then it would be 1 electron. But here we're talking about 2, so it's going to be 2 electron, right? So the value of n will be n is equal to 2. So once we put in the values, delta G naught is equal to minus 2 into 96500, right? And we do have, I think, yeah, we do have E naught cell value. So we'll put that right over here and then we'll calculate. The value comes out to be minus 45548 joules per mole. If you want to convert it into kilojoule, right, then we can put it as minus 5.548 kilojoule per mole. So we have done the first question, which is the A part. Now we will do the B part. So the question asks you how many electrons flow through a metallic wire if a current of 0.5 A, which is amperes, is passed for 2 hours. So we'll put this formula in it, right, in order to find the number of electrons. So 0.5 into 2 into 60 into 60, right? Because we're trying to turn it into, if we're trying to calculate this whole thing in seconds, right? The answer will come as 3, which is will come as 3600 coulomb. Now, the value of 1 Faraday is of this much. So, of 3600 is equal to would be 2.25 into 10 to the power 22 electrons. So, here is our answer. Now, if you're confused as to why we took this, like how did we get this value, so let me explain to you. Okay, so because of 1 Faraday, we get in this much, right? For 1 Faraday, we get in 6.023 into 10 to the power 23 electrons. But we have to find out, this is for only 1 Faraday, right? If we want to find out how much will be for 3600. So what we will be doing is that we will be dividing this whole thing by this value and then multiplying it with this value. So 6.023 into 10 to the power 23 upon 96500 into 3600, and that's how we'll be getting 2.246 into 10 to the power 22 electrons. So here's the answer, and this is the explanation for the answer.